This is going to be a review of single replacement. We saw a very brief introduction earlier, but what you need to remember is one pure element is going into one of these reactions. In this case, it would be magnesium. Another pure element is coming out of the reaction, in this case, copper. The rule to really understand is the more active metal, or in reality, the more active element in general, will become the ion. It's all based on this activity series, which metal is more active than another. So as you can see, lithium is far more active than silver, magnesium is more active than zinc, zinc is more active than copper. They go increasing reactivity up, decreasing reactivity down. If we have a case where my metal in solution is already the more active one, already the ion, no reaction will occur. To look at a couple of examples, I have zinc, which is here. I have mercury. In this case, it's mercury 2 nitrate. Mercury is not a very reactive metal. So zinc will become the ion according to my rule up here at the top. The more active metal will become the ion. Zinc will become zinc nitrate. Zinc now has a +2 charge. Mercury will go from a +2 to a 0 charge as it comes out as a metal liquid. Now the interesting thing is your precipitate here would be the metal, be a liquid metal forming on the bottom of your solution because mercury is a very dense metal. In this case, iron is the metal that is not an ion. Lithium here has a +1 charge. It already is an ion in lithium sulfate. In this particular case, no reaction would occur because lithium is already an ion and the more active metal will become the ion. In the last situation, we consider hydrogen a part of this reaction. You can see hydrogen here. Though it is not truly a metal, it does participate in the activity series. If I put lead into a solution of hydrogen ions, which would in reality be an acid, I would make lead 2 ion and hydrogen gas would be bubbling out of this solution. As I've mentioned in class, this is exactly what happened in Flint, Michigan. The lead-containing pipes in Flint started receiving water that was more acidic. Instead of from Lake Michigan, they were getting it from the Flint River, which caused a single replacement reaction where lead 2 ion was dissolving in the water and hydrogen gas was being produced. Now, you'll hear this word redox. Redox is reduction, oxidation, oxidation, reduction. What does that actually mean? If something is losing electrons, if an atom is losing electrons, it is becoming oxidized. It is undergoing oxidation. If it's gaining electrons, it sounds a little confusing, but getting electrons means it's becoming reduced. So its charge is actually getting lower is what you really need to think of there. The way I was learned is that Leo, the lion, says grr. In every one of these redox reactions, one atom will be losing electrons, one atom will be gaining electrons. Another way of remembering this is oxidation is loss of electrons, oil. Reduction is gain. So we have oil rig as another way of remembering these sorts of reactions and what happens in each case. So if we look more closely at one, I see there's an animation I still have to add. But if I have zinc plus copper sulfate becomes copper and zinc sulfate. So what's actually happening there is zinc as a metal is being dropped into a solution with an ion, copper 2 in solution, and sulfate, another ion in solution, and then it is turning into copper as a metal, which precipitates out of the reaction, zinc 2 ion, or zinc ion, which is now an ion in the solution. So zinc was a metal, now it's an ion, and the sulfate actually doesn't do anything. So what really truly happened in this case was zinc lost 2 electrons. It had 30 to start, 30 protons, 30 electrons. Its charge was 0. It lost 2 electrons, so its charge went to +2. Here's the 2 electrons coming out of that part of the reaction. This is what we call a half reaction. Zinc, in this case, was oxidized. Copper went from a +2 charge to a neutral charge, which means that it had to gain 2 electrons to cancel out that +2 charge and make it copper metal. So copper is reduced in that case. Now, if we look on the activity series, we can see that zinc is much more active than copper, which is why this reaction was able to proceed. As we just saw, this zinc is more active than copper. So whichever element is the more active one will become the ion. In this case, zinc was more active than copper. So as we know, with predicting the products, we're going to see one element go in. We're going to see one element come out. The more active element will become an ion. This can be based on the activity series of metals, but that's not the only possibility. The halogens, which are fluorine, chlorine, bromine, iodine, which get a negative charge and become fluoride, chloride, bromide, iodide, can be involved. So these are the halogens, which they be called in the periodic table, or the halides, which is any of them with a -1 charge. Now, the activity series for the halides follows their positions on the periodic table. So fluorine is the most active, chlorine is the second most, bromine third, and iodine fourth. In this sort of a reaction, we have iodine with a -1 charge. The rule is the more active element will become an ion. Chlorine currently here is not an ion. It has a 0 charge. It's a neutral molecule. Chlorine becomes a -1 to have a balance with sodium, and iodine is now a neutral atom. So really, truly what we're looking at here, we have 2 sodium ions that are dissolved in a solution. We have 2 iodides, which are dissolved in a solution. On the other side of this, we still have those sodium ions exactly where they were before. Now we have, instead of iodide with a -1 charge, we have chloride with a -1 charge. And then we have iodine now as a neutral molecule. In this case, with the halides, the same rule applies. The more active element will become the ion. Now, here where I have a little bit of a animation that needs to be fixed, I have potassium fluoride. This has a minus charge. This has a neutral charge. There would be no reaction because fluorine is more active than chlorine. So whatever element is the ion will stay the ion if chlorine is bubbled through a solution of potassium fluoride. But just to be clear, what I have here is potassium ions in a solution. I have fluoride ions in a solution, and the ions will, this is the more active element, the ion will remain an ion. So just to remember how we recognize these, one pure element in, one pure element out. The more active element will be an ion. There's our activity series again. We have 2 possible activity series. We have the metal activity series, which also includes hydrogen, and then we have the halide activity series. In this case, zinc as a metal, which is more active than hydrogen, which is an ion, because when hydrogen chloride is dissolved in water, it's a hydrogen ion and a chloride ion. The more active metal will become the ion. So zinc is more active than hydrogen, which is currently the ion. Therefore, you would have zinc lose 2 electrons. One of those electrons would go to one hydrogen, the other electron would go to the other hydrogen, and therefore we have hydrogen gas, which now has a neutral charge coming out, and zinc chloride, that zinc has a +2 charge. So zinc was oxidized, hydrogen was reduced. The actual reaction, as I mentioned earlier, zinc with a 0 charge, because it has 30 protons and 30 electrons, loses 2 electrons. If you take away 2 minus charges, you have a +2 charge. Hydrogen, which there were 2 hydrogens for every zinc floating around because of this reaction at the top, the hydrogen ions gained each gained an electron and became hydrogen gas, which then bubbled out of the solution. In this case, we have magnesium sulfate. Sulfate has a -2 charge. Magnesium has a +2 charge. So magnesium is an ion. Iron is not. What would happen in this case is, as we just saw, magnesium has a +2, sulfate has a -2. Iron has 0 charge there. In this case, we would have no reaction, or NR, as a result of magnesium already being an ion in solution. It's the more active metal, and therefore it will not cause any reaction. It will not be reduced because iron is a less active metal. Now, the other activity series we see here, we see bromide, aluminum bromide. We have fluorine gas getting bubbled through the solution. And we end up with aluminum fluoride and bromine liquid, which would be accumulating in the solution along with the water. So in this particular case, again, be aware of what you're seeing. Aluminum bromide. Aluminum has a +3 charge. I have 2 formula units of aluminum bromide, which means for every 2 units of aluminum bromide, I have 2 aluminum ions in the solution. And I have 6 bromides in the solution because 2 of these are dissolving. When I dissolve 2 formula units, I get 2 aluminum ions in the solution. I get 6 bromides in the solution. On the other side, I have the 2 aluminum ions are still there, and I get 6 fluorides. So fluorine went from a 0 to a -1. Bromine went from a -1 on 6 different molecules to a 0. So in that case, fluorine became the ion. Why? Because fluorine is more active than bromine. So bromine was oxidized, fluorine was reduced. The reaction, we have the 6 bromides here. Each of them lost 1 electron to become bromine neutral without a charge. And then fluorine gained 6 electrons overall. So there are 6 fluorine atoms here. Each of them gained 1 electron, and therefore we got 6 fluorides out of this reaction. Now, if I look to the converse of this, if I have my more active nonmetal already as an ion, so I have 6 fluorides, fluorine is more likely to become the ion. No reaction happens because fluoride will not be reduced. It will not give up electrons to chlorine because fluorine is more active than chlorine. With that, we finish the prediction of products for the activity series in single replacement reactions.